Well, what's the equation of this motion? It's y equals v naught t minus 5 meters per second squared times t squared. Or again, correct, and use the 4.9 meters per second squared, okay? For quick and dirty calculations, which I'll really do here, I'm going to use the 5. But what do you know? Or what don't you know? You don't know v naught y, right? What do you know?
Y, t.
Yeah, yeah. What you do know is that the catch occurs here at 0.9 seconds. Okay? This says then that we can find v naught t by setting this expression equal to 0.9 seconds, right? So y of t equals 0.6 meters. Y is 0.6 meters when t is 0.9 seconds. Well, I don't have room to write it down here, and we do need to solve it. I don't know if I've got, yeah, I've got something here to do this with. Actually, I've got two choices, gosh. That's convenient. Okay, so. Okay, that's what we've got. That's an easy equation to solve. It doesn't have any variables over here, so it's not a quadratic equation. Okay? Now, if you got to use this equation to solve for t, then it is quadratic, right? Sometimes you do. In this case, you don't. In this case, you have a very simple equation you can solve for v naught y. Then at that point, then you can write out the equation for y of t. Now let's do one more thing. I'm not going to throw the chalk again, just rely on your memory. How high was the chalk at the midpoint? Well, not at the midpoint, but at the high point. It's probably occurred about here. Would it have been over my head? Shoulder level? That sounds about right to me. Okay? Shoulder level. So, your hands were about there, so that's about 0.5 meters above the catch. So I'm saying, I think, and we're going to see, okay? It's inconceivable. It might turn out that my estimates aren't completely accurate, okay? We're going to say that the high point, according to what we just said, occurs at about 1.1 meters. Y equals about 1.1 meters. So this point here should be about 1.1 meters. We'll figure that out in a minute, because we're about there, okay? All we've got to do is solve for v naught y, and we've got this equation. And then if you know how to find the vertex of a parabola, or use a first derivative test or a second derivative test, you can figure out where the high point is, right? If you haven't had calculus, you're stuck with pre-calculus, but that's very easy. That's the way we're going to do it. But let's just see what happens. So, okay, well, we get v naught y equals what? 0.6 meters plus 5 meters per second squared times 0.9 seconds quantity squared divided by 0.9 seconds, right? All I've done is I've added this to both sides. That's what we get here. And then I'm dividing by the 0.9 seconds. It's simple algebra. So I'm not going to, belabor that. Okay, when you square 0.9 seconds, you get 0.81 seconds. You multiply that by 5. Okay, you get 4.05 meters, so we're just going to call that 4 meters. So you get, that's weird. This comes out 4.6 meters over 0.9 seconds. That's a big coincidence, so there's no reason this and this should be the same. So that's just the way the estimates coincidentally came out. Okay? Got to be something wrong with that, but I don't see it. Well, that means that my initial y velocity and my initial x velocity within the limits of precision here appear to be equal. So now we have v naught x and v naught y both equal to 5.1 meters per second, so that v naught is 5.1 meters per second times I plus 5.1 meters per second times j. Meaning, when I released this, it was at a 45-degree angle. I thought I released it at a lower angle than that. So, at one time or another, it appears, for the first time in my life, I was wrong about my perception. Okay? How could that be? Well, of course you know better than that. So, drawing all these conclusions from simple premises. And we're moving through an analysis of this motion. Okay, so now not what I want. I want the equation for x and y position. So there I've got my x and y equations. And I'm going to stop this video and continue with another one because this one's longer than YouTube will handle.